Forget the earthquakes. Forget the volcanic eruptions. Forget every disaster movie you've ever seen. The most destructive force on this planet doesn't announce itself with fire or sound. It doesn't arrive with a shockwave. It starts with something so quiet, so invisible, so ordinary, that most people never even notice. Warm water. Right now, beneath the surface of the Pacific Ocean, temperatures are climbing in ways that scientists haven't seen in over a century. And if the models are right, if the patterns hold, what comes next will reshape weather across every continent on Earth. This is the story of El Niño. And the 2026 version may be unlike anything the modern world has ever had to face. So, what exactly is El Niño? At its core, it's a shift in the relationship between the ocean and the atmosphere, specifically across the tropical Pacific. Under normal conditions, powerful trade winds blow from east to west, pushing warm surface water toward Asia and Australia, while pulling cooler water up from the deep along South America's coast. The system is like a giant engine, reliable, balanced. But every few years, that engine stalls. The trade winds weaken. The warm water that was pushed west starts sliding back east. And as it spreads across the central and eastern Pacific, it pumps enormous amounts of heat and moisture into the atmosphere above it. The jet streams shift. The storm tracks move. Rain falls where deserts once baked, and drought grips regions that once flooded. The entire global weather system reconfigured by water temperature. To understand what a truly extreme El Niño looks like, you have to go back to the 1870s. Between 1876 and 1878, something happened to global weather that no one at the time could explain. Monsoons failed across South Asia. Rivers dried up across Brazil. Harvests collapsed across northern China and across sub-Saharan Africa. The disruption was vast, synchronized, and relentless, stretching across multiple growing seasons on 6 continents at once. The result was a wave of crop failures so severe that entire regions simply could not feed themselves. For over a century, historians documented the suffering but struggled to explain the cause. What force could possibly have synchronized droughts on opposite sides of the world at the same time? The answer was hiding in the ocean, and the proof was hiding in the trees. Here's the problem with climate history. Weather doesn't leave a paper trail. There were no satellites in 1876, no weather balloons, no global sensor networks. Just scattered local observations, ship logs, and the memories of survivors, none of which could tell you what the Pacific Ocean was doing thousands of miles away. So scientists got creative. Trees, it turns out, are extraordinary record keepers. Every year, a tree adds a new ring of growth. A wide ring means a good year, plenty of rain, good conditions. A narrow ring means drought, heat, stress. And because trees grow everywhere in valleys, on mountainsides, across every continent, their rings form a global patchwork of climate memory stretching back thousands of years. By collecting cores from ancient trees across dozens of countries and cross-referencing them with historical ship logs and ocean sediment data, researchers were able to reconstruct what the Pacific Ocean's temperature actually looked like in the 1870s, year by year, almost season by season. What they found confirmed what the historical record had long suggested. The El Niño that struck in 1876 was not normal. It wasn't even close. Most El Niño events last around 9 months to a year. They peak, they fade, and the system resets. The 1876 event didn't follow that script. It ran for nearly 2 consecutive years, an almost unheard-of duration, while simultaneously reaching intensity levels that dwarfed most other events in the entire paleoclimate record. It wasn't just strong, it was relentless. Season after season, the disruption compounded. Regions that could have recovered from one failed harvest had no chance to recover before the next one collapsed, too. Scientists who have studied this event now refer to it as one of the most powerful El Niños of the past 5 centuries. And the tree ring data suggests that what made it catastrophic wasn't just the peak, it was the persistence. The system refused to let go. Now look at where we are today. The 2026 El Niño is already being flagged by multiple climate agencies as potentially the strongest developing event in over 100 years. The question isn't whether it will have an impact. The question is how far that impact reaches. Here's something important to understand. Drought, by itself, is not what tips a civilization toward crisis. What does the real damage is the chain reaction. Crops fail. Then, food prices spike. Then the supply chains that were already stretched thin begin to break. Regions that were food secure suddenly aren't. And the effects don't stop at borders because today's food system is global. What happens to wheat production in one hemisphere ripples through bread prices on the other side of the world within months. The 1870s world was devastated partly because it had almost no buffer. No global trade network, no emergency food reserves, no ability to redirect resources quickly. Our world today has more infrastructure, but it also has far more people, far more demand, and far more complexity in the systems that keep that demand met. More connected doesn't always mean more resilient. Sometimes it just means the failure travels faster. So, what does a 2026 Super El Niño actually mean for the weather you experience? It depends on where you live, but no region is untouched. In the Atlantic, strong El Niño years have historically suppressed hurricane activity. The same shift in atmospheric winds that causes so much disruption elsewhere creates conditions that prevent powerful storms from forming and intensifying. For the Caribbean and Gulf Coast, that's a rare piece of good news. But the trade-off is significant. Across the southern United States, El Niño winters tend to arrive wetter and stormier than usual. California gets slammed with atmospheric rivers. The Pacific Northwest and parts of Canada experience the opposite, unusually warm and dry winters that fuel early wildfire seasons. And in South America, the effects are almost paradoxical. Peru and Ecuador, sitting directly above the warming ocean, can see catastrophic flooding, while Brazil's interior tips into punishing drought. Two countries on the same continent experiencing opposite extremes at the same time. Zoom out further, and the picture grows more complex. Across South and Southeast Asia, a strong El Niño can disrupt the monsoon, the annual rainfall cycle that billions of people and entire national economies depend on to grow food. When the monsoon weakens or arrives late, rice paddies run dry, reservoirs drop, and agricultural losses begin to stack. In East Africa and parts of the Caribbean, El Niño typically brings extended dry periods, compounding pressure on regions already managing water scarcity and fragile harvests. Australia swings between extremes. Some regions face their worst droughts in decades, while others flood. The continent's fire risk soars as vegetation dries out through consecutive low rainfall seasons. The pattern, zoomed out far enough, is like a global reshuffling. Water doesn't disappear, it just moves to the wrong places, in the wrong amounts, at the wrong times. Here's where we are right now. Multiple major climate agencies have been tracking a significant warming signature developing across the tropical Pacific through late 2025 and into 2026. The conditions align with the early stages of what could become an event of historic scale. What makes this moment different from previous El Niño cycles is the baseline. The ocean, the entire ocean, is warmer than it has ever been in recorded history. Every El Niño now starts from a higher floor than the one before it. More energy available, more moisture available, more intensity available. Scientists have a term for this: a loaded system. El Niño doesn't just borrow heat from the ocean anymore, it amplifies it. And here's the uncomfortable truth that climate researchers keep returning to. The global food supply has never been tested by a top-tier El Niño in a world this warm. We are in genuinely uncharted territory. Not because the climate pattern is new, but because the world it's operating in has fundamentally changed. El Niño is one half of a larger cycle scientists call ENSO, the El Niño Southern Oscillation. The warm phase is El Niño. The cool phase, when trade winds strengthen and cold water spreads westward, is La Niña. And the two don't always look the same. Some El Niño events concentrate their warming in the far eastern Pacific. These tend to be the classic, high-impact events that drive the most dramatic disruptions globally. Others center their warming further west, in what's called the Central Pacific, with subtly different regional fingerprints. Understanding which type develops in 2026 and how far and how long it runs is what climate scientists are watching with extraordinary attention right now. Because the ocean is already speaking. The only question left is how loudly we'll need to listen.